Hello everyone, in this class we're gonna be creating our project. I'm gonna be creating a template. I'm gonna be showing what Xcode gives to us as the initial template. I'm gonna be explaining what every piece of code that Apple gave to us means, what it does. After that we're gonna be cleaning up the code, have a clean template. What I do, I save that template to myself, so when I start a new project I don't have to clean it up all over again. So I create the project first time, I go over it, I see the first time, I investigate it, I see why Apple is showing me that, then I clean it up, I make a copy, and when I need a new project I start it over from this new copy that I created. It's already clean. So that's what we're gonna be doing on this class. So let's go ahead and come here on, I have Xcode open. So I'm using Xcode 7.1. That's the latest Xcode available today. And I'm gonna be coming here and starting a new Xcode project. Then of course, we're going to be creating a tvOs application and it's going to be a new game. So let's hit next. Then we're going to enter a product name and I'm going to be calling this tvOs. And then we're going to enter the organization name. You can enter your own organization name or your own name here. The organization identifier, that's normally your reverse DNS. If you don't have a DNS, you can enter your name backward using dots to separate. So my name is Icaro Lavrador. Before I have my own DNS, I used to enter lavrador.icaro. It's just so Apple can create a boundary identifier for your game or for your application that's unique towards all the thousands or millions of games and applications that there is available on Apple Store. So that's the only reason. Then it's gonna be a Swift, and we're gonna be use Sprite kit. Be very careful here to be selecting Sprite kit and not Scene kit. We are going to be using Sprite kit. There are two different technologies. Scene kit's more for 3D technology. Sprite kit's a 2D technology that we're going to be seeing in this class. We're not going to be creating any unit tests or UI tests for this class, so just leave these two blanks. Hit next. Then it's gonna ask where you wanna save it. So let's put it, I'm gonna put it on my desktop. You can put whatever you think it's better. And please select here, create a Git repository. Git repository is a source control. If you don't know much about source control, you can watch on my YouTube channel. Look for Swift Next Step. I explained there what source control is, how I use GitHub. GitHub is a source control in the clouds where you can share your source with other people. And it's very useful. If you need some help, you can share your... It's very useful. If you need some help, you can share your code with us and we can help you very quickly. So there is no harm in leaving it on. If you put it off and you want to change it and put it back on later on, you're going to have to do this through terminal, and it's very difficult. Not very difficult, but it is difficult. So just leave it on and hit create it. So now we have our application. And let's go over, and I'm going to show you what Xcode gave to us right from the box. So it gave us an app delegate. That is a very standard app delegate, completely normal, exactly the same from any other app, iOS app that you have seen before. So nothing special here. From app delegate, I'm gonna jump into the game view controller because that is the logic how the game's gonna work. So game view controller. Actually, it's gonna come to the storyboard. So let's come to the storyboard. And the storyboard is gonna take a while to load because as you can see here, it's quite a big storyboard. And if we click it and bring it in the view controller, it's saying load this view controller, and this view controller has the game view controller associated. So like the iOS, you have a view controller, our initial view controller. You can see there is the initial view controller here. Initial view controller with view controller normally is associated. In this case, it's called game view controller. Here is the same thing. So this is the game view controller associated with the initial game view controller that is on the screen. So let's click it and go there. So we are here. That's the clicking on the arrow bring us here, it's the same thing. Now let's see what we have here. So this game view controller has the Viewdidload, and in Viewdidload the first thing it does is call super Viewdidload, as we would expect. Then it have a if let condition. So the if let is just in case it fails, it doesn't crash the application. So it fails in find a scene called game scene. It's gonna jump out of this loop and not gonna do anything. It's not gonna fail because we can see game scene is here, but it's always good to check. So if it does find it, what it does, it creates a SKView. And what's a SKView? If you want to see what's SKView, what you do is you hold command, you click on SKView, and you jump to the definition. So SKView is inherit from a IUIView, so it's a descendant of a IUIView, and it has some very cool new functionalities like show FPS, that's frame per second, show draw count, show node count. So there is some new features that it has from different from the IUIView, but it is basically a IUIView. So it creates this SKView and then turns some of this new cool stuff that SKView have on. So it turns on frames per second, that's the FPS. FPS stands for frames per second. And that's basically tell us how many times per second the screen is being drawn into your phone. And that's very good to know if your game is being taking too much resource. It's, if the game the frames per second start to drop too low, your game is getting too much resource, then you have to cut resource. But our games at this stage is not gonna be there, but we're gonna leave it on. It's good to know as well that the simulator, this doesn't work quite as well, but one thing that we can use the simulate for is we can see that if the number start to drop. So it is different, we know that, but it is constant. It's constantly different. So if it's 50% slower, it's always 50% slower. Then there is the node count. That counts, we're gonna learn what's nodes, but basically nodes are our hero, our enemies, our subjects in the screen, so the background, the bullets, everything we put on the screens pretty much is a node. And it's good to know how many nodes we have on the screens, because if we're adding, if we're removing, we can see here by the node count if we are forgetting. For example, if we have in one of the games I did before, I have some clouds going on the top of the screen just as a background thing to look nice. If when the cloud goes out the screen, I forgot to remove it, the node count would go up, and I would see that, and that would be eating my resource, would be making my game go slow, and wouldn't be a good thing. And here, with this flag turned on, I am able to see that my node count's going on. I'm forgetting to release a node that I'm not using anymore, that I should be releasing, and that kind of some light starts goes on, some flag starts goes on, and I know that something's wrong and I should go and look for it. The ignore sibling order is a flag that tells Xcode, I don't have anything special in my code, so I leave up to you whatever you want to do to draw. Do whatever you think is faster. So some applications have to turn that off because the order that things are drawn on the screen affect the user, and then they have to turn it off. Otherwise, it's not going to look nice. That's not going to be the case for us. It's not the case for most people, but it is for some other games is the case. And then what they do is they turn it off. That slows down performance, but better a game with slower performance than a game that has flickering or has other problems. So that's what this flag is a new flag. And basically how it works is, for example, if you were drawing a helicopter, and that's the example that Apple used, and that you have your sprite is divided in different nodes. So you have your missiles, you have your helicopter, you have your LSs on the top, and there are 3 different pictures. So if you are okay with Xcode in drawing all the missiles on the screen, all the helicopter, all the LSs, and just put that to true, that's what Xcode is going to do, and that's going to make much faster. If for some reason your game not going to draw well doing this way, and you have to draw missile helicopter LS, missile helicopter LS, missile helicopter LS, that's going to make Xcode draw much slower. But if your game has to draw that way, that's how it has to be. You put that flags to false, and Xcode is going to draw that way. So that's what this flag is. You're probably not going to have to worry about it, but it's good to know. The scale node aspect fill, that's saying to fill it up this screen. So the scene that we have here, so we're creating this scene and say, I want to fill it up this how view with the scene. In the aspect to fill, we're going to have problem with this aspect to fill. We're going to leave like this for now. Aspect to fill means stretch everything until you fill the whole screen with image. And I'm not quite sure why Xcode uses aspect to fill. I would use aspect to fit, and this is what will fit your code much better, because aspect to fit means stretch the screen until it fits the screen, not until it fills the whole screen. So, for example, if you look at a picture and you say aspect to fill, so let's say we have this and we wanna to fill the screen with the text. So if Xcode has to, we have it here. So if Xcode go aspect to fill, it will go until here. And now the screen is filled, but I lose the button. If I put aspect to fit, that's aspect to fit. We'll fill it up until it fits the screen, but as soon as it fits, it stops. So I have a space here empty on this right corner, but I didn't lose anything on the bottom of the screen. So that's the difference between aspect to fill, aspect to fit. Okay. Now we understand the difference between the two. We can continue. Now after that, it says present the scene. And the scene will be presented to the user. Then we have this memory warning that's going to be called in case the tvOs is running out memory. And that's we don't really need this because unless we're going to do something, we don't need it. If we have a memory warning, we're going to be seeing on the console, it's going to say memory warning, and then we can put that function there and be calling it. But in our game, we're not going to have any problem with memory. And if we do, like I said, in debug, we're going to be seeing a message calling be logged on the console saying there is a problem with the memory. Okay, so now let's go for the game scene. On the game scene, first thing's called did move to view. So did move to view is same thing than Viewdidload on iOS, and this call as soon as the view is presented. So sorry, it's the same than view did appear. So here is saying is asking for is creating a label and is asking for a font called Chalk Duster, and let's run it while I explain it to you. Then it's saying that label, the text on that label, I want it to be hello world, and I wanted the font to be 65. Sometimes you're gonna see this error. If you see it, hit OK, hit and hit run again. It has been happening quite a lot with me, and just ignore. See, it just runs fine again. And as well, normally it runs a very large screen. It's a very big screen. You can go on Window, Scale, and I run normally on 33%. I think it's a nice size. As well, it's run much faster if you run on a smaller percentage, and you can go optimize rendering for Windows Scale. Otherwise, it can be quite slow. To bring your Apple Remote, you go to Hardware and Show Apple Remote TV. Remember, I'm on Simulator here, so remember to click on your simulator before you go to these options: Scale, Optimizer, and Debug, and Show Apple Remote. Okay. So let's go back to the code. This code is saying, give me the font 65 on my Hello World font from my label that I created. And it's asking for the middle of the screen. So it's get mid x of self.frame. So self is the SK scene, and SK scene is the scene that we are working at. So this is the scene we didn't look at, but it's a very simple controller with just square, rectangle. So what's inside the yellow rectangle is our scene. So it's saying, so the SK scene dot frame is that the frame is that yellow rectangle, saying give me the middle X, give me the middle Y, and that give us exactly the middle point of that yellow square. So that give us that point right here. After that, it says self add child my label. So self again is the SK scene. So it's saying add this label that I created to that scene, and then the hello world text is displayed right in the middle of the screen, because the anchor, and I'm going to show you what the anchor is. So if I go here, let me stop this and create a label. Let me zoom in that label. Okay, so you're gonna see, if I put the center and center, you're gonna see that this point right this point here, right where in the middle of the circle is the anchor point, and that is where it's gonna be put. So if you say put it on the position 529.31, 529.733, this is the point that's gonna be on that point. So let's delete this. Let's go back here. So it's saying put that anchor point that's right in the middle of the label. So it's right here on the middle of our hello world. We are saying put that point on the middle of my square. So as we can see here, stop the simulator. But as we could see here, the hello world message was right there, right in the middle. I'll bring it up again and I'll show you. Let's go to the other function. The other function starts began. What it does is every time we touch the remote, it gets called and then looks for all the touch in the remote, asks for the location. The trick with the remote is all the touch in the remote has the same location, and all the touch locations are the center of the screen. So that's quite tricky, and we're gonna be seeing how to go around that. But every time you touch the Apple remote, the location of the touch is the center of the screen. So we're gonna see when we touch the remote, how is the spaceship's gonna be put on the middle of the screen. But what it's saying, get the locations of the touch. Then creates a sprite node. A sprite node, it can be an image, it can be a draw, it can be animation, it can be many things. So here we are creating an image of a spaceship that is here on the game assets named spaceship. So it's saying create this sprite node with the name spaceship. It's scaled to 50%, so half the size. On the axis, on the axis and the y axis, so half the size in both dimensions. Then sprite.position, so put it on this position, and this position that I wanted to be put it is the location where the touch happened. So this location is this location. It's always on the center of the screen. Okay, after that we create what's called an action. So we use skAction, and then the action is rotate by angle, and the angle is pi. Pi is a complete rotation about the center. So it's going to rotate 360 degrees in a duration of 1 second. So in 1 second, the spaceship's going to rotate about his center 360 degrees. After that, we're going to create another action. So let's look here. We're looking at this part that's highlighted. But this time, we're going to repeat the action forever. So the action is to repeat the action forever. So we are creating the action that repeats the action forever. And the action that we want to repeat forever is the action. And then what we're saying is, for the sprite that we create that has the spaceship, what we want to do is we want to run the action that we create. And the action we create is actually two actions. One of rotate the spaceship 360 degrees in 1 second. The first action. The second action, rotate forever. After all that's done, we edit that sprite node, that's a spaceship, that is scaled by 50% on the X axle and the Y axle, that is rotating 360 degrees in 1 second forever. We're gonna edit that to the screen. So let's see that happening. So there it is. So if I go ahead and click it on the remote, so to click on the remote, you click out, and then you just click it on the remote. And you can see, if I go here on the corner, if I go on the other corner, whatever I go, it's always putting the spaceship on the same place. Doesn't matter what I click. But there it is. It's creating the spaceship here, rotating 360 degrees on the center, taking 1 second to do the rotation, repeating it forever. Okay. What else? Well, then we have this function update. And this function update is calling every single frame. Remember we saw the frames update, the frames per second. So if our application run, and let's have a look here, we can see on the corner, but because my application, my simulator is 33% small, we can't really read it. But let's go here, scale to 100% and see how big it is. And I can't even so I have nodes 29, so that means I have 28 spaceships, and then I have the node hello world on the screen, and is running at 2.5 frames per second. So every second it's being called 2.9 times to be drawn this image on the screen. It's really, really slow, but because this is such a big screen and tvOs is such a heavy engine that's running. The simulator is new. It runs very heavily in my computer. If you can't quite hear, but the fans is blowing out here. It's quite difficult for my computer to keep it up, and my computer is not a slow computer. So that's why I run it in 33% and I put to optimize to a smaller size. And I normally don't really worry too much with performance on the simulator. I normally test on my proper tvOs because the simulator for me haven't been work as today very well. Anyway, let's go ahead and clean up this code now. I'll stop this so my computer doesn't burn. And let's have a look what we don't need it. So we don't need this comment because we already know what it is. We don't need touch begun because we're not going to use touch begun. We don't need this. We need did move to view, but we don't need to create any code inside did move to view. So let's leave it like this. On scene, let me see if I delete everything that I created. Yes. View controller, we are gonna leave it like this for now. We're probably gonna change game scene for home scene before, but let's leave it like this for now. Game assets, we don't need this spaceship. We can delete it. Okay, so we can see some of the icons here, and there is front, middle, and back because the icons are three-dimensional, and there is a nice effect when we click it on. And then there is the two different sides from Apple Store and from the device. There is this top shelf and the launch icon as well. For the top shelf is this, so then when we have your app here, you have the top shelf. Let me bring this simulator on a small scale again. So that's the top shelf. So there is your icon, and we're gonna be seeing that as well, more detail later on. And their playlist is very similar to any other iOS playlist as well. So that's our empty, not empty, but our default initial application that I would be using for now on when I start a new project. Is strip it out everything we don't normally need that Xcode normally gives to us when we create a brand project. I hope you are enjoying it, and don't forget, if you have any questions, as always, just ask. I'm here to help you. I hope you understand I'm going very slow. I'm having a lot of details. This is a new language. Not a new language, but this is a new platform. There's people that's will be the first time they are developing games. There is new things for everybody here, I believe. So I have been putting a lot of details in everything that I'm explaining. The lessons are going to be a bit longer than our normal lessons are. Because of that, I hope you have a little bit of patience with this. I hope you're okay with this. Let me know what you think about I'm being going so deep in every single detail about every single thing. I hope it's okay for you. If not, I maybe can do something a little bit quicker version of these tutorials, but I think it's a good idea. Have a little bit of patience. Even if you know 90% of the things I'm saying, that 10% of things you're going to learn is going to make the difference. So keep up with the lesson. Go from the beginning to the end and try to, even if you think you know everything, I'm assure you one little thing in each lesson you're gonna learn it, and that will not be worth an end, because that's gonna make the difference from an average developer to a great developer. I'll see you in the next class. Look forward to it, and yeah, hope you enjoy it. See you there.